So I'll just kind of recap on that. In the beginning, there was discomfort. Go in there, solve it. Don't just follow the industry standard. You're going to set yourself miles apart from your competition. In fact, you'll jokingly not have competition. That's what I tell people. They're like, well, you know, your competitor. Oh, shoot. Who? I haven't met them yet because we're not doing the same job. You know, recap on that. Use your senses, use your common sense, which isn't always that common, but use it. Listen, smell, take a look around. There's all kinds of hidden gems throughout a house that will alert you to things. Dirt entrainment on the grills, dust buildup around doors, a dirty line around a carpet floor on an exterior wall. These are all things that are going to start to tell you this home may be having some significant pressure issues, and we might need to investigate a little bit further. Because in the end, everybody's like, I'm not a building scientist. What do I need to know about all this? You're going to get put in the butt kicking line, no matter what. If it's uncomfortable, you get put in the line. If it's damp, you get put in the line. They don't call the builder. They don't call the insulator. Whenever that house has no insulation, they didn't call the insulating contractor. They called me. So let's not put ourselves in a butt kicking line. Let's prepare ourselves and let's prepare our clients for success. All right, so do they really need that 5-ton? So this customer needed a new system, and that piece of junk just never kept up. And several people gave him a quote and said, yeah, you're absolutely right, it's too small. Well, what did you keep the house at? Well, we were keeping it about 75, but it just ran all day long. Never turned off. Well, we might want to separate it from the attic. It's just sucking in the attic. Does anybody ever just take a look up a return air chase? It's amazing what you might find in there.
That's a return?
This is a return.
Made out of sheetrock?
No, so basically what you got here is you've got a return can, a plenum,
okay.
And then you have a wall chase.
Okay.
And so where the wall chase is, they have this plumbing, because in many of these cases, everyone in my market, they have these brilliant ideas. We're going to regain a space. And so we're going to turn this closet that used to be where the equipment was, and we're going to put it in the attic. But then they forget they still got to have a return air, and so they just put it at the top. It's pretty dumb. But at any rate, so this thing may or may not, that might have been the case, I can't remember. But one thing that is evident is the 8-inch by 24-inch hole that has fiberglass. Because everybody knows fiberglass stops nothing. Heat flow only. So at any rate, everyone told them they needed a bigger unit. Now, because we have high integrity and we sold that system, and we sold them that 5-ton that they wanted, and we show up, and during the installation, we discover that. Do we fix it?
Absolutely.
Yeah, you have to, right? What happens when you fix it? It's grossly oversized. This unit was keeping up. Barely, but it was keeping up. And we were sucking in 130-degree attic air at whatever dew point. In my particular case, 78 degrees is the average dew point. So we were like, our equipment was suffering. However, it was working. If I go in there and I do my job and I replace my equipment and then I seal that hole, I'm going to create a whole new mess. Who's liable for the new wet, nasty house? Me. Get yourself out of the butt kicking line. Don't get put in it. Identify the problem. Bring it to the customer. Let them do it. If they don't want you to do it, don't do the job. I know that's scary. That hurts. But it's a lot cheaper than being put in the butt kicking line. I told this to a guy earlier this week. What's more expensive? Well, like he said, I have to take the job because I need the money. Well, okay, you need the money. And why do you need it? And he said, well, for my family. Okay, so how much is your time worth? Because if you have to go back and do free work, how much was your time worth? Because obviously if you're doing this for your family to earn money, you can't earn any money if you're out there reworking things. So there's just no win in it. You have to solve the problems and you can't create new ones. So if all the other contractors had looked, they would have seen this hole. And you know, I'd like to think that they wouldn't be offering upsizing to solve the problem.
Did you put reheat in, like a 5 kW?
No, in almost every single case, I downsize.
You downsized it?
Yeah, because especially in this, well, and I'll get on that, but you know, we're going to seal that hole. In fact, we seal the entire chase. But whenever we do that, even the unit that was there is going to be too large. And that's where your manual J, your manual S, and all of those things that make
comes to mind when you talk about that story is, you know, some people kind of want to talk about trusting runtime data over the load calculation. It's really hard to trust runtime data in a situation like that.
Absolutely.
Exactly.
But what you can do is you can measure delivered capacity. And then you can run that against time, because then you have real-time delivered capacity. It's still no reason to not have a proper heat gain loss calculation done. But, and I'll get on some of that kind of hip math. Everybody blames the brand. Thank goodness for Goodman, it's Goodman's fault. It's Trane's fault, it's everybody else's fault. It's obviously not the install. That's a 12 by 12 ceiling can, ceiling boot, whatever you want to call them in your market, P-box, with a 10 by 10, with a reducer, with a piece of flex tied to a triangle Y. And fun fact, they weren't complaining about it. They had no idea. They just got a bigger system. That's how they fixed it. And none of those are attached to anything. They're all just sitting on top of each other. Not even good duct tape or nothing. But if we're going to go out there and we're going to replace this equipment, now that's an extreme, obviously, but let's solve these problems. If you're evaluating the equipment before you ever sold it, and you notice that they've got tremendous amount of buildup on the evaporator coil, should you sell them a piece of equipment or should you sell them a duct job? You should probably sell them both, but you for sure have to sell them a duct job.
Give them choices, yeah.
Sure, yeah. I mean, like, you know, you can tier it for somebody. However, if they choose not to seal up the ductwork, do they want to pay you to do a bad job? And if the coil gets dirty, are they responsible for it, or are you responsible for it? Take yourself out of the butt kicking line. Seal it up. Some cases, it's just too simple. You don't even, I mean, obviously we have to charge for what we're worth, but take care of the simple stuff. Whenever you see things, goes back to, yeah, it's not what you do. Not everybody in here is insulators. However, unfortunately in our business, we have to be counselors, we have to be building scientists, we have to be HVAC guys, we have to do all kinds of fun, crazy things. This is an attic knee wall, and this is some insulation that's in it, and then obviously areas that there's nothing in it. Does anybody know how many points of contact insulation requires on a vertical? 6. How many times do we see it with 6 points of contact? And if you're wondering what I'm saying is drywall, 2 by 2 by, top plate, toe plate, and then another piece. You shouldn't be able to see the insulation. If you can see the insulation, it's missing an air barrier. It is not performing to the standard that it was tested at, or to the performance data that it was tested at. It's much lower. And so making recommendations to solve these problems. No, they might not need more air in that room. What they need is they need to fix the house. So, you know, be willing to have those conversations. So, you know, keep your head on a swivel. Be very familiar with building assemblies and get to know air barriers, thermal barriers. Where should they be? Where should they not be? So that as you're going through things, you can present better options and you don't get mean looks on your face in crawl spaces. Poor indoor air quality. So it's just my opinions per se, but duct sealing is critically important to indoor air quality. This installing contractor decided that it would be best to take the flexible duct and just shove them in the holes. There's nothing there, it's just flex duct shoved in the holes, and they went ahead and they went the extra mile and they did mastic the seams. It's insanity. They mastic the seams for the code inspector so that he would make them happy. But going back to what we're doing out there is we're there to change their lives. We're there to change everything. We have an opportunity to solve these problems. Let's solve them. Do not ignore that just because they paid somebody else to do it. Bring it to their attention. They will always, not always, but they will almost always buy in to solving the problems. And for the guys that come out of the sales class, that UV light is keeping that gas valve as clean as it possibly can. Accessories are accessories. And there's a place for them. That's not one of them. And I'm not telling you what you should or shouldn't do as far as it goes with that. But if you're going to utilize an accessory, be sure that you know what you're doing with it. Don't just reward people for selling things. In the system sizing selection and listening to the client, it's important to evaluate the home, the thermal barrier. Why do they have 42 inches of insulation in this attic? It's weird. That's a lot. What were they trying to solve? Did it fix the problem? No. It made that problem worse. Those people are currently not living in their home. It's being gutted. They added the insulation to solve the discomfort, and as a result, it's raining inside of their walls. It did not solve any problems. And I'll be happy to talk on that after class. Manual D, ductwork, and flex. Flex gets a really, really, really bad name. And it can be done beautifully. In fact, my first experience with NCI was I sent them a picture of a flexible duct system on the like good, bad, and ugly type post, and I won. And oh, what is this? And it was on a flexible duct system. And because that's around this time. Does anybody know the name Joseph Stiebert? I know some people in the room do. But him and Allison Bales and several others, there was lots of talk through the building science community about flexible duct. And so I took it upon myself to take a picture of one I did. This one I did not. That is no longer whatever we thought it was. So it's only going to move as much air as we allow it. That was the problem. They didn't need a new system. They didn't need a bigger system. They needed to fix the duct. Follow Manual D. Follow the best practice, best installation practices, and ensure that you've tested out to make sure that you've hit those marks so that you don't get put in the butt-kicking line. You can measure the system's performance. We have the tools nowadays to do so. Equip yourself. Does anybody use any of the wireless probes or Measure Quick or anything like that in the room? Yeah, a little bit. If you're still using handhelds, that's fine. I encourage you to step outside of that range and equip yourself with probes, and you'll wonder why you have waited this long. A set of wireless probes will give you information in minutes that it took you hours, and it's no more gratifying getting it from your screen than it is beating it on a pen and paper. All right, so, and I'm kind of all over the place with this, but why not just match the equipment? I think we've pretty much covered that. matching the equipment would lead to disasters in all of these cases. Taking a full evaluation of the home is so much more important. Mad air. Is anybody familiar with the term mad air? A little bit. So what mad air is, it's a very, very cool study, and it's on the mechanical air distribution and its interactive relationships. Yep. Chris Hughes for the save twice today.
I thought it was going to be shorter than that.
Right.
MAD?
Yeah. So mad air is the study of those doors slamming closed. And what does that do? So believe it or not, one of the largest, if not the largest driving factor in North American homes is mechanically driven infiltration. So how the HVAC system interacts with the house. As it pushes and pulls on the house. Is it going to be pushing the air that it's supposed to be circulating out of the house, which in 1 CFM out, 1 CFM in, we're going to be pulling in a lot of outdoor air and pushing out a lot of the bought and paid for air. It's a real fascinating study. It's available online. You can reach out to me. I'll share it. And you can use your DG8 or equivalent manometer to find out all kinds of interesting things, like why is the subfloor of that building negative, and why is that bedroom have 32 pascals of pressure on the other side of it? That's a lot of pressure, and it needs to be addressed. So using the roomulator, you can solve a lot of those issues.